Hello students, welcome to Math Center Web Coaching. In our last video, we have seen what is matrix, what are the different types of the matrices, right? Now in today's video, we are going to see what is adjoint of the matrix. Now in today's video, I am going to show you two methods to solve the adjoint of the matrix. One is our conventional method, and the second I am going to tell you the tricks to solve the adjoint of the matrix, so that by using the tricks you can calculate the adjoint of the matrix in fraction of seconds. And in GET exam or in Maharashtra Engineering Services, like competitive exams, you can use that trick to calculate the adjoint of the matrix. Okay, now where we use this concept, that adjoint of the matrix, to calculate the inverse of the matrix, we use the adjoint method. Okay, so by using this formula, A inverse is equal to adjoint of A upon determinant of A, we can calculate the inverse. Okay, now in 11th and 12th standard, you must have come across with the concept inverse of the matrix, right? Now in engineering, we are going to see how to calculate inverse by using the adjoint of the matrix. Okay, but before that, we need to calculate adjoint of the matrix. So let's see. So for adjoint of the matrix, we need to calculate, or we need to have a square matrix, then minus, then cofactors, and then adjoint of the matrix. Okay. Now what is minus? What is cofactors? So minus are basically denoted by MIJ, MIJ. Okay. Or you AIJs also. But basically, I usually prefer MIJs. Okay, so you can use MIJ also or AIJs also. Now next, CIJs, that is cofactor matrix, that is CIJ. Okay, so cofactors are denoted by CIJ, and adjoint of the matrix is denoted by ADJ of A, or A is your given matrix. If A is your given matrix, then you can show it by ADJ of A. Okay, so ADJ of A is nothing but the adjoint of the matrix, and which is equal to, okay, which is equal to transpose of the cofactor matrix. So here I have mentioned that Cij, this is the cofactor matrix, okay, and we need to calculate the transpose of the cofactor matrix, and transpose is denoted by capital T, small t, or dash. We have seen already in our last video, right? Transpose of the matrix, that is nothing but the interchanging rows and columns. So adjoint of the matrix is nothing but the transpose of cofactor matrix. But what is cofactor matrix? Okay, how will we find out the cofactor matrix? So to find out the cofactor matrix, we need to have a minus first. Okay, so what is minus? So minor is nothing but, for that we need to have one square matrix. So suppose A is my square matrix. A, B, C, and D. So this is my 2 by 2 square matrix. Now we have to calculate the minors, and minors are denoted by Mij. Okay, but remember that minor, this term is related with the elements of the matrix. That is, we need to calculate the minor of A, minor of B, minor of C, and minor of D. Okay, these are my elements of the matrix, and we need to calculate the minor of A, B, C, and D. Okay, so first I mentioned that M11, this is the minor of A. M12, this is the minor of this B. Now C and D. So minor of C is denoted by M21, and minor of D is denoted by M22. Why? Because of their position. Because A lies in first row, first column. So the minor of A is denoted by M11. B lies in first row, second column. So minor of B is denoted by M12. C lies in second row and first column. So minor of C is denoted by M21, and minor of D is denoted by M22, as D lies in second row and second column. Right? Now next step is how to calculate these minors. Okay. So there is a, now we need to calculate the minor of A. Okay. So A lies in first row, first column. So we need to hide this first row and first column, or corresponding row and column of that element we need to hide. And the remaining element is nothing but the minor. So minor of A is D first. Okay? Now second, 1, 2. That is minor of B we need to calculate. But B lies in first row and second column. So we need to hide that row and column corresponding to B, and the remaining element is nothing but the minor of B. Okay. Now we need to calculate the minor of C. Now what is the position of C? So second row and first column we need to hide, and the remaining element, that is B, is our minor of C. Now last, minor of D we need to calculate. So what is the position of D? Second row, second column. So we need to hide that. And the remaining element, that is A, is the minor of D. So these are the minors. Okay. Now what about cofactors? So cofactor, there is a mathematical expression for, or you can say the relation between cofactor and minor. So what is that? Cij is equal to minus 1 raised to I plus j mij. So this is the mathematical expression or relation between Mij and Cij. So what it tells? Now suppose this I plus j, this addition is even, then Cij is equal to Mij. And if this addition I plus j is odd, then Cij is equal to negation of Mij. Let's see how. Now this is the mathematical representation, right? So what is that? The Cij is equal to minus 1 raised to I plus j mij. Now suppose this I plus j, this addition is even. So let's suppose that I is equal to 1 and j is equal to 1. So 1 plus 1, 2, right? So minus 1 raised to 2, that is even number, will get 1 again. So in that case, Cij is equal to mij, right? And in second step, suppose I plus j, this addition is odd, then Cij, obviously, suppose minus 1 raised to I plus j is 3. Okay, that is odd number. So minus 1 raised to 3 will gives us minus 1. Okay, so in that case, Cij is equal to minus of mij. Right? Okay, so when we use this to calculate the cofactor matrix, we are going to use this concept. Okay, Cij's are nothing but Mij's for the even place, and Mij, Cij is equal to minus of ij for odd place. Okay, so Cij, this matrix will become now M11. Now what is this position? 1 plus 1, 2, even. So we have to copy this D as it is. There is no need to change the sign of D, right? Because 1 plus 1 is 2 and that is even. What about 1 plus 2, right? This is 1 plus 2, that is 3. So we need to, and 3 is odd, so we need to change the sign of C. So our this element will become minus C. Okay. Now what about this B? That is minor 2, 1. So 2 plus 1, that is 3, and it will become minus B, and A as it is, as 2 plus 2 is 4, and that is even. So A, we don't need to change the sign of A. Okay. So this is our cofactor matrix. So B minus C minus B A. This is my cofactor matrix. Now we have to transpose this matrix. Okay. So what is transpose of Cij or cofactor matrix? Transpose is nothing but interchanging rows and columns. So in this, my first row will become my first column and my second row will become my second column. So in this case, B minus C minus BA is the transpose of the given matrix, that is Cij. Now Cij transpose of this matrix, and that is nothing but our adjoint of given matrix A. Okay. because see here, adjoint of A is equal to transpose of Cij, and here we have calculated the transpose matrix of Cij. So this is our adjoint of a matrix. So this is the conventional method actually. First step we need to calculate the minors. Second step we need to calculate the cofactor matrix by using this sign conventions, and then take a transpose of that cofactor matrix, and then lastly you will get the adjoint of the matrix. Okay. Now let's see the example. Adjoint of the adjoint of a 2 by 2 matrix. Okay. Now here, this is my conventional method. I'm going to solve this example by conventional method, and here I'm going to solve this same example by tricks, by using the tricks. Okay. So let's start. Now the conventional method, that means we need to calculate the minors first, then second cofactor matrix, and then last we need to transpose the cofactor matrix, and then we can calculate the then we will get the adjoint of the matrix. Okay, so let's start. A is equal to, this is our given matrix, 2, 3, 4 and 5. This is our square matrix 2 by 2, right? Next we need to calculate the minus first. This is our first step, right? So what is minor? M11, M12, M21 and M22. Now M11. Now M11 is the minor of 2. Okay. So what we are going to do? We are going to find out the minor of this 2. So we need to hide this row and corresponding row and column of 2, and the 5 will remaining element. So 5 is nothing but our minor of 2. Okay. Now third, 3. Now minor of 3. We need to calculate minor of 3. Okay. So what is the position of 3? First row and second column. So we need to hide that corresponding row and column, and 4 will remain, and therefore 4 is the minor of 3. Now what is the, sorry. Now minor of 4 we need to calculate. Now 4, the corresponding row and column of 4 we need to hide, and 3 is our minor of element 4. Okay. Now 5. Now minor of 5, we need to hide the corresponding row and column of 5, and 2 will remain as it is. So therefore 2 is our minor of 5. Okay. Now these are our minors. Now what about Cij matrix, cofactor matrix? So cofactor matrix Cij is equal to, what is that? 5, 4, 3, 2. But we need to add here sign conventions, right? So what is the sign convention here? Addition. If here, as we have seen here, if addition is even, then Cij's are equal to Mij's, and if addition is odd, then Cij is equal to minus of Ij. So 1 plus 1, 2. So there is no need to change the sign of 5 as it is. Now 1 plus 2, there is 3, odd number, right? So we need to change the sign of 4. So this will become minus 4. And here 2 plus 1, again 2 plus 1 is 3, that is odd. So we need to change the sign of 3 here, right? And here 2 plus 2, this is 4. So there is no need to change the sign of 2, right? So this is my transpose cofactor matrix. Okay. So cofactor matrix. Now what is next? Cij, transpose of Cij, that is cofactor matrix, transpose of cofactor matrix, right? So what is transpose? My first row, that is 5 minus 4, will become my first column, and second row will become my second column. So this is transpose of cofactor matrix. Okay, so transpose of cofactor matrix, and transpose of cofactor matrix is nothing but adjoint of the given matrix, that is Aj of A. Okay, so this is my conventional method. Okay, now we see the adjoint, how to calculate the adjoint of 2 by 2 matrix by using the trick. Okay, So what is the trick? The trick is very simple. In single step, okay, in single step you can calculate the adjoint. Now what is the condition to calculate the adjoint of this A? So there is a condition that we need to interchange the diagonal elements. So what is the first condition? We need to interchange the diagonal elements. And so suppose adjoint of A, let me write first. Okay. So what is the first condition? We need to interchange the diagonal elements. This is the condition for diagonal elements. Okay. So we need to interchange. So that is, this is 5, this is 2, right? And what is the condition on non-diagonal element? Non-diagonal elements are 3 and 4. Okay. So we need to change the sign of non-diagonal elements. Again, I repeat. Okay, non-diagonal elements, we need to interchange, we need to change the sign of non-diagonal elements, and for diagonal elements we need to interchange the position. Okay, so this is my adjoint of A, right? So in simple single step you can calculate the adjoint of the matrix. Okay, and this trick you can use in competitive exam. Okay,